Welcome to this episode of Easy Physics, where we delve into the fascinating world of science and uncover the secrets behind some of the most significant scientific projects in history. In today's episode, we will be exploring the Manhattan Project, a monumental scientific endeavor that forever changed the course of human history. The Manhattan Project was a top-secret research program that took place during World War II, aimed at developing atomic weapons. It was named after the Manhattan Engineer District of the U.S. Army Corps of Engineers, which oversaw the project. The goal of the project was to harness the power of nuclear fission to create a weapon capable of unprecedented destruction. To fully understand the significance of the Manhattan Project, we must first explore the scientific principles that underpin it. At its core, the project relied on the understanding of nuclear physics, specifically the concept of nuclear fission. Nuclear fission occurs when the nucleus of an atom is split into two smaller nuclei, releasing an enormous amount of energy in the process. The scientific groundwork for the Manhattan Project began in the early 20th century with the discovery of radioactivity by Marie Curie and the pioneering work of physicists like Ernest Rutherford and Niels Bohr. These early discoveries laid the foundation for the understanding of nuclear reactions and led to the development of the atomic theory. The project itself began in 1939 when Albert Einstein wrote a letter to President Franklin D. Roosevelt, warning him of the possibility that Nazi Germany might be working on developing atomic weapons. This letter prompted the U.S. government to take action, resulting in the creation of the Manhattan Project in 1942. Led by physicist J. Robert Oppenheimer, the project brought together some of the brightest scientific minds of the time, including Enrico Fermi, Hans Bethe, and Richard Feynman. The research took place at several secret locations, the most famous of which was the Los Alamos Laboratory in New Mexico. One of the key challenges faced by the scientists involved in the Manhattan Project was the production of sufficient quantities of fissile material, such as uranium-235 and plutonium-239. These materials are essential for sustaining a chain reaction in a nuclear weapon. The project utilized various methods to produce these materials, including the enrichment of uranium through gaseous diffusion and electromagnetic separation, and the production of plutonium through the irradiation of uranium in nuclear reactors. The Manhattan Project also required the development of complex engineering and technological infrastructure to support the research efforts. This included the construction of massive facilities, such as the Hanford site in Washington and the Oak Ridge facilities in Tennessee. These sites were responsible for the production of the fissile materials needed for the project. Despite the significant scientific and engineering challenges, the Manhattan Project made rapid progress. One of the key breakthroughs came in December 1942, when Fermi successfully achieved the first controlled nuclear chain reaction at the University of Chicago. This achievement demonstrated the feasibility of sustaining a self-sustaining nuclear reaction. The culmination of the Manhattan Project came on July 16, 1945, with the successful test of the first atomic bomb, codenamed Trinity, in the desert near Alamogordo, New Mexico. The explosion produced an immense amount of energy, equivalent to approximately 20,000 tons of TNT. This test confirmed that the project had indeed achieved its primary objective. Following the success of the Trinity test, the U.S. government made the fateful decision to deploy atomic weapons against Japan. On August 6, 1945, the first combat use of an atomic bomb occurred when the city of Hiroshima was devastated by the detonation of the Little Boy bomb. 3 days later, on August 9, 1945, the city of Nagasaki was similarly devastated by the detonation of the Fat Man bomb. The bombings of Hiroshima and Nagasaki resulted in the immediate deaths of over 200,000 people, with countless others suffering from the long-term effects of radiation exposure. The devastation caused by these bombings led to Japan's surrender and ultimately brought an end to World War II. The Manhattan Project was a monumental scientific and engineering achievement, representing a significant turning point in human history. It ushered in the atomic age and forever changed the geopolitical landscape of the world. The project demonstrated the immense power that could be harnessed from the atom, while also raising profound ethical and moral questions about the use of such destructive weapons. In the aftermath of the war, the scientific knowledge gained from the Manhattan Project paved the way for further developments in nuclear energy and peaceful applications of atomic science. It also led to the establishment of international efforts to control and prevent the proliferation of nuclear weapons, such as the creation of the United Nations and the subsequent signing of the Treaty on the Non-Proliferation of Nuclear Weapons. The legacy of the Manhattan Project serves as a reminder of the immense power of science and the responsibility that comes with its discoveries. It highlights the importance of ethical considerations and the need for responsible scientific research. The lessons learned from this project continue to shape our understanding of nuclear physics and influence the way we approach scientific advancements in the present day. And with that, we come to the end of this episode of Easy Physics. We hope you found this exploration of the Manhattan Project informative and thought-provoking. Join us next time as we delve into another captivating scientific concept.